So Tom can paint a fence in 6 hours. Huck can paint a fence in 4 hours. And if they work together, how long would it take to paint 5 fences? Okay, this is a typical work problem. What we're going to do is put together the formulas and then merge everything together to create the equation we need to find out how long it would take to paint 5 fences. Of course, we're using the assumption, by the way, that Huck will not have to paint the fence by himself and that Tom won't trick him. We're going to assume they're going to both paint at their proper rates and get it done. Anyway, let's start with our formulas. If you recall, distance equals rate times time. And really, that's just a formula for measuring the rate of something and how long it takes to accomplish that feat. So in the case of the fence, we're going to say work equals the rate times the time. Okay, of course, which means the rate equals the work divided by the time. Okay, so let's take a look. The rate for Tom. Okay, so Tom, his rate would equal 1 fence per 6 hours. So that's Tom's rate. And then Huck's rate, okay, is 1 fence per 4 hours. Okay. And if they work together, how long would it take to paint 5 fences? So that's what we need to develop an equation for. So let's write it out. So again, go back to our original idea. Work equals the rate times the time. The work that's going to be done is 5 fences, so 5F. Okay, and let's start with Tom. Tom's part of the fences, these 5 fences, is going to be his rate, which is 1 fence per 6 hours, times the amount of time he works. Okay, and then Huck's amount of time he's going to contribute is going to be T as well, and he's going to be painting 1 fence per 4 hours. Okay, so there you have it. This is going to be Tom, this is going to be Huck, and that's the 5 fences. Okay, so it's a standard fractional algebra problem. We want to solve for T because we're looking for time, how long, and we have F. So what we're going to do is let's multiply this denominator. Here's a 4 and a 6. Let's multiply the whole thing by 24 hours so we can get rid of these denominators. Okay, so if we multiply by 24 hours, okay, 24 hours times 5F is going to be 120 hours times F, and that's going to equal, multiply this, the 24 hours and 6 hours cancel, so it's 4 hours. So this is going to be 4 hours FT, okay, and then plus 24 times this as we distribute is going to be 6 FT. I shouldn't have put the hours here because these hours are actually going to cancel. So we have 120 hours F, 4 FT because the hours cancel, and then 6 FT because the hours cancel. So what are we left with? We're left with 120 hours F equals 10 FT. And notice how I left the units in there. I like working in that way because it helps me actually reassure myself that I'm doing it properly. If I had the fractions backwards or if I miscalculated something, the units would not line up. So now what we're down to is we have 120 hours F is equal to 10 FT. We can divide both sides by F, so these cancel. Okay, and then finally we can divide both sides by 10, and we get 12 hours equals T. So again, our units line up. We have 12 hours equals T, and that's how long it will take to paint 5 fences. Okay, now let's check our work. Okay, if they work for 12 hours, okay, Tom is going to paint 2 fences because he can do 1 every 6 hours, so that's 2. And if they work for 12 hours, Huck is going to get 3 done because he can do a fence every 4 hours. So that's correct. Let's crank through one more example of a work word problem. Here we have a garden hose that can fill a pool up in 8 hours. That's a rate issue. And we have pipes that can fill the same pool in 90 minutes, a different rate, a different method. If you use both sources together, how long will it take to fill the pool working together? So similar to the other problem, let's set up our equation. We know, again, work equals the rate times the time. And of course, we can determine from that equation that rate equals work divided by t. So let's take a look at what we've been given. Okay, the garden hose in the pool. So the rate of the hose is going to equal work, which is one pool, divided by 8 hours, or every 8 hours. And at the same time, the pipes, okay, are going to be, the rate of the pipes will be one pool divided by 90 minutes. Okay? Now, knowing these two rates, we're trying to find how long it will take to fill the pool. We can go back to our original equation, work equals rate times time. So the work for one pool will be, one pool will equal the rate of the hose. Okay, so it's one pool per 8 hours times the time that it's filling up, plus the rate of the pipes, which will be one pool per 90 minutes times the time. And here's our equation. We need to solve for t. Okay, so how do we go about doing that? Well, the first thing I want to do is I notice that there's 90 minutes and 8 hours, and I'd like to actually switch that around because if we can't use 90 and 8 together, they're different units. So let's change the I'm going to actually change the minutes. Let's change this into 1.5 hours. Okay, so one pool will equal one pool 8 hours times t plus one pool 1.5 hours t. Okay, and again, like the other example, there's different ways to do it, but the way I like to do it is take the least common multiple of these two, which it turns out is going to be 24, and then multiply it throughout the whole equation to get rid of the fractions, and now we're working with just regular numbers. So we multiply the whole thing by 24 hours. We get 24 hours times one pool equals, this times this whole thing is going to become 3p times t. Okay, the hours and cancels, plus this 24 divided by 1.5 is going to be 16. Okay, so this becomes 16p t. Okay, is equal to that. And finally, we combine like terms and we get 24 hours pool equals 19 pool t. Okay, divide both sides by pool, get rid of that units. Alrighty, and then lastly, we take 24 divided by 19, and I'm going to pull out the calculator. So 24 divided by 19 equals 1.26 hours. Okay, that will be how long it will take if they work together. Then if you want to do a quick check, 1.26 hours, okay, we multiply that times one pool per 8 hours, so that'll be 1.26 divided by 8. So the hose will fill up 0.157 pools, okay, and then the other one can do 1 divided by 1.5, so that'll be 1.26 divided by 1.5 equals 0.84 roughly will be the pipes contribution, and that does actually add up to one pool. I wanted to throw in one quick variation. If you remember from our previous example earlier in the video, we had Tom can paint a fence in 6 hours, Huck can paint a fence in 4 hours. How long would it take to paint 5 fences? In this example, I just want to quickly show what happens if Huck shows up 3 hours late. Okay, how do we construct this equation? Okay, So again, we always go back. This is a work problem. So work equals the rate times the time. Okay, and as you remember from the other parts of the video, Tom's rate is equal to 1 fence per 6 hours. And then Huck's rate is 1 fence per 4 hours. Okay, and again, we're going to go back to paint 5 fences. The amount of work is going to be 5 fences. And that's going to equal the amount done by Huck, which would be a rate times the time, which is 1 fence per 4 hours times his time. And then, of course, Tom is going to be 1 fence per 6 hours times his time. And we're going to add, so this is Tom's contribution, this is Huck's contribution. And again, going back to our new criteria, Huck is 3 hours late, okay? Which means Tom is going to spend T time painting, and Huck is actually going to spend 3 hours less painting, okay? So basically, we have a new equation with a slight variation, but we'll solve it the same way. Okay, what I like to do again is get rid of these denominators. So I'll multiply by the least common multiple, which is 24 hours. So this now becomes 120 hours times fences, which equals 4 fences times t plus 6 fences times t minus 3. Okay, and then we just distribute the parentheses, and we can actually divide everything by fences. These are all common, so we're left with 120 hours is equal to 4t plus 6 times t minus 3, and 120 hours is equal to 10t minus 18. Therefore, 138 equals 10t. So the new time will be 13.8 hours. If you recall, in our other example, it took 12 hours together. But if Huck shows up late, 3 hours late, it's going to take them 13.8 hours working together to make up the difference of his being 3 hours late. So basically, Tom is going to be working 13.8 hours, and Huck will be working 10.8 hours. And so we'll quickly check. So for Tom, it's 13.8 hours divided by 6. He'll do 2.3 fences. And then Huck, who paints faster, even though he showed up later, will end up painting 2.7 fences. So again, it adds up to 5 fences, and that's the breakdown.